Polar graphing. In this video, we're going to discuss how to graph a point on the polar coordinate system. Let's start, as we often do, with what we know. We already know how to graph Cartesian coordinates, which are also called rectangular coordinates, using the xy, x being the distance left or right, and y being the distance up or down. So here's an example, the example of the point 2, 2. Well, we would go the x distance is positive 2, so we would go 2 to the right. The y direction is positive 2, so we would go 2 up, and our point 2, 2 in rectangular or Cartesian coordinates is right here. So 2, 2, because they're both positive, this tells us we want to go right 2, because we have a positive 2, and then we want to go up 2, because we have a positive 2 here in the y position. In polar coordinates, which is just another way to graph points, each point is represented by a distance, how far away the point is from the origin, and an angle, which will be positive or negative from the positive x-axis, and is measured in either degrees or radians. So let's take our point 2, 2 again. So here's my xy coordinate. This is the point, I'll put a 2 here. So we're relabeling our point 2, 2. Okay. In polar, we want to know the distance away from the origin, which we're going to label r. And we want to know the angle, positive or negative, from the positive x-axis, and that is theta. Okay. So rectangular says go over, go right or left, and then up or down. Polar says find the angle and then go out to get to the point. So let's take a look. What are r and theta in this simple example? Well, r, you'll know because of the Pythagorean theorem, is 2 times the square root of 2. So this is a right triangle. This leg is 2, this leg is 2. The square root of 2 squared plus 2 squared is 2 root 2. Theta, because I've drawn this point to be on the y equals x line, this theta is equal to 45 degrees. So theta in this example is 45 degrees, or in radians, it's pi over 2. Okay, so our point 2, 2 in rectangular coordinates is equivalent to 2 root 2, I put a comma in there. I don't want the comma in there. Is equivalent to 2 root 2, comma, 45 degrees, or 2 root 2, comma, pi over 2. And those are the two of the possibilities in polar. So again, rectangular, right or left, up or down. Polar, the distance away from the origin and the angle to get there in either degrees or radians. Okay. Some notes, and then we're going to do some polar graphing. Polar graphing is very nice for working with curves, which is why it can be popular. Okay, polar graphing is often done on a polar coordinate graph. And here is a polar coordinate graph down here, which we're going to use in our example. It includes concentric circles with equal space between them. So I'll slide up a touch and you can see all of these concentric circles with equal space between them as you work your way out. Okay, and it includes spokes, which are lines out from the pole. In polar graphing, the origin is called the pole, and these spokes indicate angles. So as you come out here with these spokes, you can see that these have been labeled in radians. This spoke represents an angle of pi over 12 radians, again from the positive x-axis. This spoke represents from the x-axis an angle of pi over 6 radians, and so on. Okay, I'll slide up a touch, and let's take a look at this. In polar coordinates, the point is indicated, as we've seen, as r comma theta. R represents the distance from the pole, or the origin. Again, here's the pole. And theta represents the angle from the polar axis. So the polar axis is the same as the positive horizontal axis in polar graphing. Note, both r and theta can be positive or negative. So you can do lots of things as you go around in either direction and either out this way or out this way from the pole. So one point can have numerous names in polar graphing. While polar coordinates are written r theta, you want to find theta first. You want to organize yourself by first getting a hold of where you are in terms of the angle, and then you want to go out the distance r. So we want to find theta first. So a little bit backwards from rectangular. Okay, let's use our example. In example 1, let's use our polar graph. Again, this polar graph is in radians to label the following 4 points. Okay, point A. Our r is 3. Our theta in radians is 2 pi over 3. It's positive, so we're going to go around to 2 pi over 3, which is here. Again, theta first. And then we're going to go out 3. So from the pole, I go out 1, 2, 3. And right here is the point A in polar coordinates. Okay. In letter B, we want to notice that the r is negative, which means we don't go out, we go back. Okay, so this kind of represents a go backwards after you find the angle, as opposed to going forwards after you find the angle, you're going to go backwards. So let's see how that works. Again, first find the angle, pi over 6. Well, pi over 6 is positive. Here's pi over 6 right here. So we're on this spoke. But we want to go back 4. Okay, if it were a positive 4, we'd come out 4. But it's a negative 4, so we find our angle, we go to the pole, and we go back 4. 1, 2, 3, 4. And this point this is the point B, which is negative 4 comma pi over 6. Notice again, the same point, we could have gone around all the way to 7 pi over 6, and then we would have gone positive 4 out. So again, in polar, lots of possibilities for every point. Okay, letter C, we have a negative angle, which means we're going to go from the polar axis in the clockwise direction and a positive r. So let's find negative pi over 4. Well, here is positive pi over 4, which we went up 3 to get to. So negative pi over 4 will go down. So 7 pi over 4 is equivalent to going clockwise pi over 4. So there's our angle. So we're on this spoke right here. And we want to go out positive 5. So we're here, find the pole. 1, 2, 3, 4, 5. And right here is the point C. Okay. And finally, our point D, we have a negative r and a negative theta. And again, remember the negative r tells us that we're going back once we find our theta. Negative pi over 2, well, here's positive pi over 2, which is going up halfway around, a quarter of the way around. So from here, we'll go negative pi over 2, which is the same as this, as 3 pi over 2 in the positive direction, in the standard position direction. So our angle of negative pi over 2 is here. So we're on this spoke right here, this vertical spoke, and we want to go back 6. So we start here, we go back 6. 1, 2, 3, 4, 5, 6. And right there is the point D. So polar graphing takes a little bit of extra time and work because of all the options. But remember that you first want to find your theta, either going positive or negative, and then you either go forward or backward, depending upon a positive or a negative in your R.